Hi, folks. Good morning. My name is Julian Dunn. I'm a Senior Director of Product Management here at Chainguard, and I will be joined by a few of my team members to go through a little bit more of a deep dive of our product innovations that you heard from Dan and Kim and Matt and the whole team this morning at the keynote. So without further ado, let's just dive right in. So you saw a couple of variations of this diagram in Dan's keynote, and as we deep dive into those innovations, I just wanted to reorient you as to what parts of that stack that we're talking about when we talk about these various innovations. So Chainguard libraries are these components that you see that you can build into your custom code to remove the supply chain risk, or as you can see, at some point in the future, they will also be built into our application container images. You can use Chainguard libraries on top of common Linux operating systems, such as Red Hat 8 or Ubuntu 2004, or of course, you can use them on top of Chainguard OS in our images or inside our VMs for complete supply chain protection. Now, Chainguard containers are our existing product line, and those come in two flavors, as Dan was talking about this morning, which are the base language images that you see on the left, where you can deploy your own custom code, or application images, which are effectively off-the-shelf open source software, like Nginx or Postgres or anything like that. These are the items that we will redistribute to you, but with zero CVEs. And finally, there are the Chainguard virtual machines, or VMs, which you can use as the container runtime for your containers in any of the major clouds. So I'm going to start at the top of the stack and work my way downwards, joined by a few of my PMs to talk about their specific areas. So let's talk about Chainguard libraries. I've been helping to get this off the ground. Jason Van Ziel, who you heard from this morning, he doesn't know this, but I actually started my career as a Java software developer long time ago. I'm not quite as old as him, but getting close. And I was one of the first folks that migrated the company I was working for from Apache Ant, if anybody remembers that, to Apache Maven, because who liked downloading jars by hand from the internet and trying to glue them all together? And when Maven came along, it had this POM, and you can just describe all this, and then it was magic. Of course, I didn't know the supply chain risk at the time. The magic of downloading random stuff off the internet and building your project, like that was a great user experience. But 20 years later, I think, oh man, that's a big supply chain risk that you have, definitely. So I have been very happy to help get this project off the ground. So Chainguard libraries are closest to your applications. In fact, your application code typically depends on that stuff directly, like your jars or your Python wheels, to work. So what problem are we solving with this product? This is your typical software supply chain for open source libraries. These jars or these Python wheels or Ruby gems or Conda packages or whatever it is you call them in your own ecosystem, the source code lives in some repository system like GitHub. And they go through some kind of build process. Hopefully it's in CI/CD, like maybe GitHub Actions, which is what I was doing before I came to Chainguard, or something like that. Hopefully it's not built on your laptop under your desk. Then they go to some distribution point, like Maven Central or PyPy.org or npmjs.org or whatever. Now, every language ecosystem has a distribution point, or what is often called a public registry. Okay. If you're an attacker, there are a lot of bad things that you can do and a lot of attacks that you can launch against this supply chain. Now, the easiest thing that you're probably going to do is you're going to attack the build and distribution systems. And why? They are a lot easier to get control of than to try to break into GitHub and to modify the source code. To modify the source code, you would actually need to gain the trust of maintainers on that open source project. Plus, you're going to leave a paper trail around. If you make a commit to Git, if you're an attacker, that's going to show up in the record for that project, and then people can see what you did, and you're probably not going to be as successful. So even this xzutils attack that happened last year, it was widely misunderstood as a source code attack, box A, because it happened to occur against GitHub, but they didn't go in and modify the source code. It also took them 2 to 3 years to actually put in place kind of like a sleeper cell attack, gain the trust of the maintainer, but they didn't modify the source code. They just used that trust relationship with the maintainer as leverage to compromise the build system. So if you instead look at these sorts of attacks over the library supply chain over the last few years, you can see that they are predominantly concentrated in boxes B through F. So let's talk about a few of these examples. An attack against the build system, for example, is this Ultralytics vulnerability that happened, which is somebody was able to break in and compromise the GitHub Actions CI workflow that was going on, and injected malware into that, and then published new versions of this Ultralytics library that weren't reflected in the source code. And because there are multiple versions of this Ultralytics package, they were able to publish multiple versions of this to PyPy package releases. And this is a widely used AI library with 60 million downloads. And because it's so easy for developers to bump the dependencies, this got injected into a lot of production software out there before the maintainers were actually able to realize this and roll this back. A couple of examples of distribution attacks. Now, these attacks are somewhat hard to explain, but just to illustrate how vulnerable these public repositories are. In the case of MavenGate, in Apache Maven or Maven Central, you can only publish to Maven if you have you have a group ID if you're a Java developer, and that group ID is typically a domain name, and you have to have a special DNS record in that domain name in order to have the rights to publish to Maven. Well, if you're an attacker, you can go in and try to find what developers let their domain names expire. And if I register that domain name and I put in that special record, now I can compromise those packages, which are sometimes load-bearing in the Java ecosystem. That's what happened in MavenGate. In the case of Lottie Player, which is a JavaScript library, and a few of these other attacks, the attackers, there's a couple of vectors into this distribution system. Compromising dev auth tokens, stealing the developer's upload credentials to the registry, or similar. Now, a lot of these registries have, over the last few years, tried to implement multi-factor authentication for uploads. I should know, I was at GitHub when we tried to do this, tried to implement multi-factor authentication for NPM. But even in NPM, we could never get all the way there. And even today, if you read the docs, in NPM is only enforcing multi-factor authentication for the top 100 or so packages. But think about how big the JavaScript ecosystem is. So this is not a sufficient protection against these sorts of attacks when these takeover attacks can happen at any layer of the dependency chain. Okay, now if you're a company and you recognize that this is a problem, you're sort of stuck between a rock and a hard place if you want to address this. One thing is we've sort of seen two approaches to this. One approach is that companies, many of them are actually ignoring this risk. They let developers pull directly from Maven Central or PyPy or other such registry systems, even in CI/CD, which opens up enormous risk for you. And coupled with those helpful tools like GitHub Dependabot, which shows a little green dialog box and says, oh, merge this immediately once it's a new version of that dependency, that it's an easy green button for developers to mash whenever there's a new version of that dependency that's published to these systems, whether or not that's legitimate or not. So that path from exploit to compromise can be vanishingly small and almost automated. So that should keep up CISOs at night. Or the other thing that we've seen, the other approach that we've seen in companies is to try to curate the acceptable libraries yourself. So maybe that's some kind of manual approach. We've seen some companies forcing developers to open a ServiceNow ticket every time they want a dependency added to the acceptable list. And someone will eventually look at that ticket, maybe weeks later, and see if it's safe to import that library into Artifactory and proceed. This is kind of ridiculous. Developers just want to move quickly, and also the person looking at that ticket, how do they actually know if the thing is safe or not? There's also, at the OS level, we know that there's tens and thousands of packages, but the library level, there's hundreds of thousands of packages, or sometimes millions of libraries. So how is anybody actually to go through and determine if something is safe? Another variant of this approach is also to maybe put in sort of policy-based approaches or rules into their artifact management systems to try to assess whether those libraries are safe as well. But again, those rules can't keep up with the fact that many of the millions of libraries are out there, new ones are being published all the time, new versions are being published all the time, and these attacks are so rare. These attacks are so rare. However, these rules just can't keep up with that velocity that the ecosystem is moving at. Okay, so there is a third way. Now, what if we went back to the source that's on the left-hand side, the actual source code for these libraries, and rebuilt them all inside our existing hardened factory that you heard so much about in that keynote? And if we completely bypassed Maven Central, PyPy, whatever, and deliver them directly to you with the same kinds of attestation and provenance information and signing that you've come to expect from Chainguard images, well, that's exactly what we've done. Here's how it all works. We rebuild those Maven projects from their true source in the factory. We deliver them to your artifact manager, that's Artifactory or Sonatype Nexus or Cloudsmith, and you can consume our libraries as your sole source. You can still use Maven Central as a fallback if you wish, but most companies are eventually going to, we believe, are eventually going to use us as the sole source. These libraries get consumed by your developers using the normal build processes with no visible changes to them. Now, you can crack open any one of these jars that we have and look at the build receipts to verify they're the ones that you got from Chainguard and not from the outside world. And those receipts also provide some metadata about the build environment, et cetera, and they're also signed. Okay, so the outcomes you get are that you no longer need to either ignore this problem or try an impractical manual or rules-based curation approach. We become your sole source for libraries built within this hardened environment with end-to-end integrity and integrated out of the box with common artifact managers. Plus, you don't need to change the developer workflow at all. They don't notice whether or not it is that they're building on their laptops or in CI/CD. Okay, so Java support for Chainguard libraries is available today in beta. We are working on other language support too, based on customer demand and effort. So if you have feedback for us on which ones we should prioritize, please let us know. I didn't happen to include a demo today because honestly, it's so easy to adopt that the build process looks the same before and after. And who wants to watch, everybody's seen a Maven project compile. Nobody needs to see more demos of that. But if you want to see a demo, please find members of the engineering team or myself after, and I can introduce you to folks and we can talk about showing you a demo of how it works. All right, with that, I would like to turn it over to a few of the folks on my team to talk about two important new features in our existing product line, Chainguard Containers, and that are custom assembly and EOL grace period. So I'd like to welcome up Saurabh Kadi, who is product manager for custom assembly. Saurabh?
Awesome. Thank you. Hi, everyone. I'm very thrilled to be able to talk to you about custom assembly today. Before I dive into what the solution is and also a live demo of custom assembly, I want to quickly cover why we decided to build custom assembly. What was the real-life feedback that we saw from customers who were trying to deploy and customize our images, and why did we need to build a solution? So here is the very common deployment pattern that we saw across most of our customers. Every organization is different, and there are some unique traits to how an image gets customized and deployed. But largely, this was the pattern that we saw. So we're going to use a Python image as an example here. So Chainguard, we produce a Python image that's minimal, 0 CVEs, and guarded. Usually when a customer, an organization goes to pull it, it's usually a platform or an SRE team. It's a central platform team that pulls down the image into their internal registry. They might do some minor customizations here. So this is the first round of customizations. So here they might add packages for compliance needs. Maybe they might need to add some cryptography modules. There might be some packages to add for developer experience. Maybe they want to include tools like Bash, curl, or JQ. These are common tools that their developers need in order to just run an image. There are a couple different reasons, but really there were about 3 or 4 common use cases we saw across all the customers that we talked to. On the right side, on the application teams, when they received the images from the platform team, there were no rules to what kind of customizations they did here. They were pulling in basically any package they need in order to make their application run, and there was not a lot of oversight into what kind of packages they added and what were their requirements. So this was a situation that we were encountering very often. There's 3 issues with this situation. The first one is that it's very difficult to scale. If it was exactly like what I had shown in the slide, which is 1 image, 1 platform team, 3 app teams, we could maybe find a solution for it. But imagine in real life, there's probably 10 images on the left side. Then there's maybe 5 platform teams, maybe 1 for every business unit. And then there might be 10 application teams that every platform team is responsible for. So you can start to see how complicated it gets very quickly. Second issue is that developers might pull insecure packages from insecure sources. These packages might have supply chain vulnerabilities, CVEs, malware in there. So you need to make sure that you're pulling from secure sources. The more customizations you make, the more at risk you're putting your images. And then finally, it's expensive to maintain. Matt Moore, our CTO, talked a little bit about our factory earlier in the keynote. We have invested a lot of time and effort into building out that factory. It takes a lot of compute resources, it takes manpower, it takes time. In fact, across all our customers, we saw that it takes about 2 engineers, about 2 months to build something like, to just customize images. This is rough and depends on the scale of the organization, but it's very expensive. So, what's the solution, you might ask? That's a great question. Chainguard Custom Assembly is the solution. So it's a powerful tool that allows you to add packages to any entitled image that you've purchased from Chainguard. As part of Custom Assembly, we've also built a private APK repository. This repository houses all of the packages that are part of the images that you've purchased, and you can add those packages into any of the images through Custom Assembly. I'll get into it a little bit in a couple seconds in the demo, but once you've customized an image, you can just pull it down like you do any other regular image through Chainguard and start using it right away. So with that, I am going to jump into a demo here. So let me move over into this screen. Okay, awesome. Glad that we got this practiced and working. Here we're looking at the Chainguard console. This is where you can go in and manage all of your images that you have and versions and CVEs that are in the images. This is also where you use custom assembly. We do have a CLI aspect as well, but today I'm going to show you the UI aspect. So this is an image that's called Node Custom. It looks like every other image that you have in Chainguard, except for there's a Customize Image button up here. So we will click it, and up comes a side panel. So there's a couple of very interesting things about this side panel that I'll walk through from top down. First, you can see that it's based off of the Chainguard node image, and let me zoom in a little bit just so that it's a little bit more clear. So this is just a demo, so that's why we based it off the node, but you can base it off of any image that you've purchased from Chainguard and start customizing it. And then down here is you can see a list of packages. So it's just a giant list. So this is the private APK repository. This is where you can see all the packages that you have access to, and then you can add them into your images. And you can do it very simply just by checking a box and including them. So here maybe I'll add BusyBox is already added. So I can just maybe look for curl, and curl is there. And I'll mention two very important things about the package APK repository, private APK repository, sorry. First is that since the packages come from images that you've purchased and are guarded by the CVE SLA, these packages will be CVE free. That's very important. You're not pulling from an insecure random source on the internet. You're pulling from Chainguard. We take the time to secure these packages. Second is that we manage the dependencies of any package that you want to add. So for example, curl is a pretty simple one, but let's say if you were mashing together Python and Java together, let's say you start from a Python and you want to include Java as a customization, you just check the Java OpenJDK package and we will figure out what are the dependencies of OpenJDK and we will pull them in for you. You don't need to go in and figure out what the dependencies are and check them yourself. This is very helpful in case the dependencies change in a newer version. So we maintain all of that, we track all of that. All you need to tell us is, hey, we want OpenJDK in this Python image, and we'll take care of the rest. So those are two really big benefits with the private APK repository through custom assembly. So curl is checked, I click preview changes, I can see that I'm about to add curl to this node custom image. I click apply changes, and that's it. So it says that the build has been kicked off. This build happens in our infrastructure, in the Chainguard infrastructure. So we will make it available to you. I'm hitting refresh here. It'll show up in probably a couple seconds. And this build only takes like a minute or two. Just due to time restrictions, I won't wait around to show you that it's done, but you can see it's already being kicked off. Once the build is complete, you can go to the versions tab here and pull this image down, just like you do every other Chainguard image, either by the pull URL, by the image name and tag, or by the digest, and your developers are ready to go. So that's it. That's custom assembly in a nutshell. Switch over to the slides now. So just to kind of sum it all up, here at Chainguard, we've taken the time to put together a world-class software factory, which pulls the latest source code, builds it, scans it, and patches it every single day. By using custom assembly, you can rely on Chainguard to deliver the image that you need so that you can focus on problems that are more important to you in your business. You don't need to rebuild this kind of a factory. You can just rely on Chainguard custom assembly to do that for you. And looking ahead, right now we're in beta. We plan to GA in May. But we're not done there yet. We've received some very fantastic feedback from our design partners. Some of who are here at Assemble, I don't know, I can't see if you're in this room or not, but because of that feedback, we are planning to make some improvements post-GA2 to support even more advanced use cases. You can take a look at what kind of use cases there are. And if you have any feedback or if you'd love to try it out, please let me know. And thank you so much. And up next, I'll pass it over to Tony.
All right, thank you, Saurabh. Hey everyone, I'm Tony. I'm a product manager here at Chainguard, and I want to talk today about a new product that we have called the End-of-Life Grace Period. Now, this is a product that's currently in beta, but we plan on releasing it later this year. Before we get to any of the details of how the EOL grace period works or what it's doing, I want to just talk about why we built this. So despite best efforts, some organizations still rely on end-of-life software in their applications. Because it's end-of-life, it's no longer receiving any updates from the open source community, which reduces its security and leaves it vulnerable for CVEs. Oftentimes, updating to a newer version isn't possible before it reaches its end-of-life date. So we've created an end-of-life grace period, which provides you an extension to your timelines without sacrificing the security of your container images. But what does it do exactly? When an image is labeled end-of-life, Chainguard will automatically detect and apply updates to the package dependencies, improving its security and reducing its CVEs in these end-of-life images. And Chainguard will continue to rebuild this image, applying the updates for up to 6 months or until the rebuild fails. To better understand the details, let's take a look at some timelines here. And now this is a real-world example. This is Node.js version 18. And while Node 18 was a long-term supported image, it was created back in 2022, and you get about 3 full years of support and updates and CVE remediation in that Node image from the Node community. The end of life, if you can notice, is coming up in a few weeks, and hopefully everyone in this room that's using Node version 18 has already updated to a newer version, right? Everyone's updated, right? Okay, well, if you haven't updated, that's all right. We got your back. So if you have the end-of-life grace period, Chainguard will continue applying updates to this image for 6 months after that April 30th, 2025 date, giving you additional coverage until October 30th, 2025. Now, if we're going to take a look at what's happening under the hood here, I'm going to show this example. Now, this is a fake example, but it's to give you an idea of what we're doing. We have Ruby 3.0, and on the left-hand side, you have Ruby 3.0. It's reached its end-of-life date, and inside of this image, you'll have the primary dependency itself, which is the Ruby 3.0. That's end-of-life, no longer receiving any updates from the community, and you have a list of its package dependencies underneath. So you can see the package dependencies that are outlined in red or highlighted in red have some updates that are available that could be applied to this image. However, if you're relying on the open source version of Node 18, you're not going to get updates to those images. If you have the end of life grace period with Chainguard, we will apply those updates for you automatically. We will detect when they're available. We will rebuild this image for you and then deliver it to your repository. So the result that you have here is that this new image has an increased level of security, and it's less likely to accumulate these CVEs over time. All right, so kind of wrapping up here, we have a few important takeaways in that with the end-of-life grace period, you will receive up to 6 months of updates, extending your timeline as you migrate to a newer version. During this time, your EOL images will receive updates to their package dependencies, improving its security and reducing all of its CVEs. Remember, though, that this, even with an extended grace period, you'll get an extension to your timelines. However, these images remain inherently risky. So even though you're covered, we still recommend that you update to a later version. All right, that's really all the time I have for today. I'll be at the Ask the Expert booth on floor 4 all day today. So if you have any questions, please come by and ask. I'll do my best to answer all your questions about all the product lines that we have here. And thank you very much for your time. All right, next up, I want to introduce Mark Baker to talk about a brand new, exciting project that we've been working on. Mark.
Thank you, Tony. So as Tony said, my name's Mark. I'm also a product manager here at Chainguard, and I'm going to talk to you about Chainguard VMs. Really exciting this morning to see Dan announce that in the keynote earlier on. There's been a lot of work over the last few months to be able to get this into place. So Chainguard VMs came about because customers loved running our container images, loved the fact that they were zero CVEs, are getting access to the latest technologies, and said, well, look, we have other areas that we run, obviously our open source applications, and we'd love to get the same experience there too. So it was really developed from a need from those customers. As Dan said, right, we started with Chainguard OS, right? And because it didn't have a kernel, Dan, he described it again this morning as being an undistro or distroless, right? A Linux distribution that was an undistro. And so to create a VM, obviously, we need to turn it into a distribution. Now, it's a little more complicated than just adding a kernel. Creating Linux distributions actually isn't that hard, but doing them well is much more difficult. So what did we do? Well, we took exactly the same approach that we've taken with our containers. So we build directly from source. It may have been easier to go and base on a distribution, an existing distribution. And in fact, that's a question we get asked often when we've spoken to some of the design partners that we've been working with is, what are you based off, right? Is it Fedora? Is it Debian? Right? Is there something else? And the answer is nothing. We build directly from source. Because the Chainguard promise, if you like, our value is that we build from source and secure the entire supply chain. Right? If we were to base off something else, we're taking a dependency that we can't assure, that we can't secure. So we build directly from source, right? And through that build system in the factory, you'll see that it's secure by design. The build system is all automated with manual intervention where required, right? But we are remediating the CVEs as they appear upstream, rebuilding the image and making that available. The VM itself is built. So yes, we've added a Linux kernel, and I'll show you some of that in a minute. but also various other components that we need to make it be able to execute as a VM. Systemd, right, to be able to manage services within your environment. And then libraries, example here is glibc, that your applications depend upon to be able to run and execute. But then there's whole sets of different applications that you may need. And it depends very much on your policy and your organization. So if you need a package manager, we can provide APK and APK tools. If you need SSH access, if your application needs SSH access, so you can go in, look at the application real time, make changes if you real time if you need to, we can provide SSH. But equally, we get a lot of requests saying we don't want SSH, right? So you don't have to have that. The cloud agents to be able to manage different aspects of the VM environment. And then, the container runtimes, because we're very much focused, certainly at this stage, on providing a VM to run your container applications, your Chainguard containers. All of these VMs, we aim to be, of course, free from CVEs. Right? The moment CVE is remediated upstream, re-roll, make that available to you. They're designed for ephemeral environments, right? So much as we love and have great respect for those long-running VMs that are running big enterprise applications for months or even years on end, we're not targeting those environments, right? These are for ephemeral workloads. Minimal by design. So the only packages that should be inside the VM are packages that are required to service the workload that you're running. And then secure by default, as you come to expect from Chainguard. So let me jump into a demo. Good, it looks like we're on screen. So I'm going to move into Amazon EC2 console. So I'm guessing most of you are familiar with this. You'll see we have a whole set of instances running. If I go and look at these instances, I'm going to just filter based on name contains, and I have set that this curious name. Let's do that again. Name contains. There we go. So you'll see I have 4 nodes here running that actually go to form part of a cluster. I'll come on to explain in a minute. A couple of AL 2023 nodes, some Chainguard nodes, of course, and some Ubuntu 24.04 nodes. So typical kind of operating system mix that you may see in your environment. Let's go and jump into the Chainguard node. And you can see it's built from a Chainguard AMI, Amazon Machine Image. And it has all the information that you would expect. So a typical VM, nothing revolutionary here. But what we can do is go and jump in. Let's go and connect to that instance. So I'm going to connect using Session Manager. Cross my fingers. And the shell should come up. I'll make that, is that visible at the back? Shall I make it a little bigger? A little bit. So, okay, good, thank you. So we have a standard prompt. I'm going to just make that interactive. So I can see, and you'll see nothing sort of revolutionary here so far. So we have some file systems, as you'd expect, right? We have some processes, as you'd expect. So again, like a typical Linux distribution that you'd see. You'll notice in this particular instance, we have a number of container runtimes operating. Again, I'll show you some of that in a second. But I wanted to call the attention here to the systemd units. So we had some debate. We want to create a minimal image, right? We want to provide a way to be able to manage services. Systemd, as you probably know, is the de facto standard way of doing that in a Linux distribution. Systemd doesn't always necessarily sort of go well with minimal image. So, but we've done a lot of work to just include the modules, the systemd units rather, that are required to be able to run the services, the applications that are going to be required. So still keeping it minimal, and I'll show you some of that. I'll also, let's get you back to the top so you can see there, also see that, right, we have a kernel. I want to draw attention to this because it's running, as you see here, the AWS kernel. So several months ago, in fact, probably more than that, we hired some kernel engineers who are experienced working with other Linux distributions, let's just say that. So, and gave them a task to say, look, we want to create optimized kernel environments, so turn Chainguard OS from an undistro into a Linux distribution designed to run container workloads on the 3 primary clouds. And so for each of our VM images, we have versions for the 3 primary clouds. And each of those contains an optimized kernel designed specifically to run these container workloads, right, across a variety of the different instance types that are available. So let's just jump out of that. Now, and go back to this. There we go. Hopefully that's still visible. So yes, as you will have seen, right, I have these nodes running. These form part of a cluster. They're actually part of an Amazon EKS cluster, right? And we have this cluster here, the wonderful Mongoose cluster, cunningly named. And again, we go and click on compute here. We'll see that we have these 3 node groups, AL 2023, Chainguard, and Ubuntu. Again, this is a fairly typical. In each of these, we're going to look at one of the nodes. So let's go and take a look. We'll start with we'll start at the top, the Ubuntu node. Here, this is 2404 again, so it's just over a year old. But you can see kernel version here. It's running a 6.8 kernel. So that's 12, 14 months maybe old. Now, I think that's still supported upstream. But it's not necessarily going to contain all the latest innovations to be able to take advantage of networking enhancements, processor scheduling enhancements, whatever has come since that 6.8 kernel was released. It also may not have all the CVEs addressed in it. Right? And you can see here that we're running kubelet because it's a container runtime VM. And so we're running 1.3.2. That's fairly recent, right? It's not necessarily the most recent, so it won't necessarily have all of the latest innovations and features. We jump back. Let's go and look at AL 2023. Now, this is running an older environment, right? It's running a 6.1 kernel. Again, sort of heavily patched by Amazon to run in their environment. This is nearly 2.5 years old, right? So it's probably about 2 years, 3 months, something like that. And so once again, right, you have to ask yourself, is that going to provide me with all the capabilities and features that I want to be able to take advantage of, right? Is it going to have all the latest innovations that I need? And likewise, running kubelet version, again, an EKS patch version, but 1.3.2.1, again, not too bad, but not the latest version. If we jump back here, and of course, finally take a look at the Chainguard node. Here, we're running a 6.13 kernel. So this is from January, right, from upstream. So we are staying current with upstream stable kernel releases. As I say, it's been optimized by us for use, in this case, on AWS, specifically for this container environment. We're running kubelet version here, 1.3.2.3, the latest edition. And again, that kubelet version has been compiled. It's been through all of our factory, our build system, so to remove any CVEs that we found or address and remediate those CVEs so you can be safe knowing that you're running a secure environment. So let's jump back into, or not jump back into, let's jump into AWS Systems Manager. So again, you probably saw this morning, Dan referenced cloud agents, right? So part of building this VM environment for these cloud providers is not just adding a kernel and adding some systemd and some various other components. To run effectively and efficiently, you need to provide cloud agents. Now, it's up to you to decide whether you want to run those cloud agents, right? You may have other ways of performing fleet management, systems management, inventory management. You may not use Systems Manager, but we provide the capability for you to do that if you like. And so these images, we've installed the AWS Systems Manager agent. Again, because that's open source, it's available, we've put that through our build system in exactly the same way. We go and take a look at, now I've preloaded these because there's too many nodes here and I was worried I was going to get it wrong. But we go and explore some of these nodes. First, oh, there we go, it didn't work. The great best will of men. But let's go and take a look at the Ubuntu node to begin with. And we'll take a look at the inventory. Take a second to refresh. But here, 393 applications. This is a standard install of Ubuntu 24.04. A great general-purpose Linux OS, I hasten to add. But here we're obviously using it as a VM in an EKS cluster, as a compute node host. So 393 applications. That's quite a large set of applications, right, for you to be able to manage, keep up to date with CVEs. And it represents quite a large attack surface area, right? We're going to do the same. I'm probably going to have the same issue here. Oh, no. So on the AL 2023, here we've got 344. So it's slightly fewer, slightly less packages, but still a reasonable amount to keep, for you to keep in track. You've got to ask yourself, are all these packages essential for running a compute node host, for running my containers? Well, I can tell you, we have a slightly different view, right? We have, with Chainguard, we have less than half. Right? And that's because we've gone through rigorously this process of ensuring what is it we need to run these container environments as part of EKS, and only included the applications that are required. We give you access to the latest versions, latest stable releases of each of these packages, so whether it's the AWS agents, the kernel, containerd, kubelet, kproxy, whatever. Right? And we say, again, as Dan was saying this morning, we re-roll those images every day. Now, it's up to you how often you deploy those, but we're speaking to customers that have targets about node replacement every 30 days or sometimes faster than that. But if you want to, you can run a zero CVE environment, a VM, every day if you wish to. So I think that's bringing me up to the end of my time. I'm now going to, if we switch back to the slides, if you have any questions about VMs, then I'll obviously be available after this session, and so I'd love to chat with you. But if we switch back to the slides, good, we're back on those. This is something that we're announcing today. So VMs is obviously something that we've announced today. We are in early access. So if you'd like to try out VMs, we've got these available, obviously as part of Amazon, which I've shown you today, but on, of course, GCP and Azure too. If you'd like to have try these out, we'd love to get your feedback. It's your opportunity to help shape the direction and what things you'd like to see as part of a VM. And yeah, please come and talk to me or follow the link or the QR code. Thank you.
Thank you, Julian, Tony, Saurabh, and Mark. We have a few minutes left that I'll save for questions, but just quickly, this session will end at 11 o'clock. We'll have a 15-minute break. If you stay in this room, you'll get to hear Dylan from Booz Allen Hamilton talk about deploying Chainguard images to meet a set of DoD requirements, how Booz went around actually implementing Chainguard solutions and the challenges they faced with their migration and how they solved them. Also downstairs, we have a deeper dive into the Chainguard factory by Dustin Kirkland, our VP of Engineering. And we have a workshop specifically focused on debugging Chainguard images. So maybe in the 3 minutes left, anybody have a question they want to ask of the product team who I'll invite back up stage? Good.
I got a question. Do you have any solution for the ARM side of the AWS? And the other question I have is, one of the problems you're facing with container Kubernetes is the 30% overhead, because the Kubernetes don't really have a kernel to run, and that became a problem when running AI, because we're 30% CPU idling time without doing nothing, and it costs a lot of money. That's one problem. Optimization, containers, one of the problems we're facing is we're loading applications, the database internal keep increasing index on the DRAM, so they just use up whatever you give them. Mm-hmm. So optimized container sometimes is not preferred for that reasons. So that's our experience.
Okay, thank you. And so certainly address the first part of your question, which is probably easier than the second part. So yes, we are building for ARM. So again, we didn't sort of want to go through it all, but we're building for ARM on all three of the clouds. And so those will be available for you to try out. The second part, I'm not sure I quite understood, but you're saying in terms of the AI container images, if we've created an optimized environment?
The Kubernetes is have a 30% overhead. So you run the AI peripheral on top. That 30% overhead choke the AI GPU phase.
Got you.
So far, there's no solution to get around the problem, but they charge you the clock at 100%. Mm-hmm. So we pay 30% premium. So if you pay software, you pay 30% more software.
Got you.
And then you realize that 30% you can reduce by not doing Kubernetes.
Got you. Got you. So, I mean, if I kind of summarize your question, I think you're asking, are we looking at the possibility of running an AI workload directly in the VM? Yeah. Yeah. Right now, we're very much focused on container workloads, but I'd love to talk to you about your use case and see how we could cater for that.
If you all want to head out to the next session, please do, but we'll let others ask questions. So I'm going to pass it to Sean from Shift 5.
Any future support for bare metal or other hypervisors?
Absolutely love to discuss that with you. Right. Okay. So our priority has been, as I say, getting off the ground with the 3 primary clouds. But yes, we'd love to expand that to other hypervisor environments, be that other clouds or potentially on-prem. So because anywhere that customers run Chainguard containers today, absolutely is a priority, and however they run them. So yeah, again, we'd love to follow up with you. I know we're already talking with you guys about something. Yeah.
Hey,
Anybody else?
Yeah, I have a question about the custom assembly. The workflow that was demoed, can it be done through Git to avoid multiple source of truth? Like, I don't want like 2 different source of truth. Like, one is the Chainguard UI, another one is Git.
Yeah, it's a good question. It's coming. That's an ask we've heard from many customers. It's coming. It's something that I'm working on.
Okay.
So if you're interested, I'd love to work with you on that.
Sure. Yeah, sounds good. Thank you.
My question is regarding the VMs. You mentioned that we are going to upgrade or patch the kernel version every now and then to the latest one. But our requirement for the application is to have a pinned version of kernel because the application supports it and the underlying things that we are using is specific to that particular kernel version until unless those things are patched. So in this case, like, how do I control that layer?
Yeah, so it's it can be a bit misleading to say we're going to like produce a new image every day. So in the same way that we do with containers, patches are applied to a kernel, and I hope you apply patches to your kernel, right? So you apply security fixes to the kernels that you're using, I should say. So if we're on a 6.13 kernel, right, we will apply patches that land in that branch upstream and make that available. We're not automatically going to upgrade you to a 6.14 or a 6. We'll have those images available, but we'll continue to maintain the branch of the 6.13, right? So it's not one day you will automatically find that you're now running a 7. Whatever kernel in place.
Got it. Second follow-up question on that was, though you mentioned this is for ephemeral VMs, though that is good. For example, my applications which are there, I have thousands of proxy machines or something, very, very specific thing. The problem is to upgrade those machines, bringing those down and bringing them up, that requires a downtime.
Yep.
I can't afford that. So how do I make sure that I patch that particular live instance running with that CVEs? Is that something that you guys are thinking of, or it's only for this?
No, absolutely it's something we're thinking of, right? So yes, we're targeting ephemeral workloads. Yes, node replacement is definitely a thing in that kind of environment. So if you're running like auto-scaling groups and stuff like that, yeah, node replacement is certainly a thing. But we've also had those exact comments from customers that node replacement is expensive, right? Because I need to migrate workloads between different nodes. And so we are definitely looking at how we can do basically AB or image place upgrades, so such that it's effectively a few seconds that you'll be out rather than potentially minutes or even an hour when you're looking at node replacement. Not that you'd be out, but you have to maintain multiple VMs at the same time to cover the workloads. So.
Awesome. We unfortunately have to end this session to get prepped for the next one, but the product team will be available for in-depth conversations on the 4th floor. Find any of the 4 folk ups here, KMR, CPO, or the other product managers, and they'll be happy to talk to you about it in more depth. Thanks again for everyone for attending the session.